And then I wanted to talk a bit about reactive programming because you are a fan of that.
Yep.
Maybe you want to say what it actually is, what are the
Yes.
benefits of it, and what is the alternative to reactive programming? So what did we do before this was invented, basically?
Okay, so what people used to do before they either recognize the thing that is called the observer pattern is that they had these mutable variables everywhere, but when something changed, they would also need to invoke some function right after it, right? Like they were like, I changed this method, and then it's like on text changed right after that, for example, which is, I guess it makes sense to some degree, but now you need to remember that each time you mutate this variable, you need to call this method that emits a change. Now you can say that, hold on a second, I can just extract this function, say that set text, and it would expose that this.text again equals text, and then notify observers. But now you have actually already invented observers. So what people used to do without the observer pattern is just have mutable variables randomly and then just mutate them randomly and read them randomly and end up with this 1600 lines of code with a bunch of checks for these booleans. Is this boolean still set this boolean, la di da. And what you end up with in the end is a bunch of callbacks in that, yeah, this updated, and then you end up with a lot of temporal coupling in your code actually. What this means is that when this happens, this also needs to happen, and it needs to happen in this order. That's what temporal coupling means. So without the observer pattern in this case, you would need to remember this coupling, that this needs to happen right after this one, and you manually need to notify this. And this is okay at first. You do it twice and you're like, wow, this is a bit shady, but okay. But when you do it like 6 times, or as to why MVP as a design pattern on Android was never a good idea, you end up doing this each time when there's a change or when you're restoring your state in the presenter, right? Like you would need to invoke the right callbacks in the right order to set up the right thing of the right state of another object. You end up seeing that this doesn't even work. So MVP, as people used to do it, was basically just a non-reactive way of state management, and it basically has all of the problems of this coupling that is required, that you need to remember exactly what callback to call after a given property is changed. But when you have reactive programming, which you can do easily with either behavior relay from Rx, with mutable live data from, well, a safe state handle, because why else would you have another one except for loading state? That shouldn't come from a safe state handle. But anyway, so with mutable live data or a state flow, flows in general. So you have these, and they are nice because when you change the property, this observer logic, this callback, is basically part of this type. Like you cannot change it without this listener being called. Like all of this is just a wrapper around the observer pattern, but because they have this shared wrapper, like either live data or Rx is observable or flows, you can apply additional operators to them, including things like filter, and then say that I don't need to know about these unless this condition is met. Or something that's like basically the foundation of reactive state design is combine. You can combine any number of these flows and observe that if any of these have changed, then I want to be notified. So imagine that you have these 4 properties setting up a view, like this search text is needed here, this filter is needed here, like there you can exact example, you can search for a title with an edit text, there's a filter for a type, and let's say there's also a date filter for whatever reason. And this is 3 different fields, 3 reactive fields, each of them can change independently. So when you mutate them, then each of them changes independently. That means you don't need to say dot value, copy, blah, 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 because they are all independent. So they are independent observable fields, you combine them, and the way you get your final result for this result filter is that you have all 3 properties. When either of them changes, you get a notification for it. You just return the query results from that, and tada, you have the asynchronously evaluated results based on these three properties, instead of having to be like, when this changed, then call this callback and hope for the best and then notify the view and all that. No, you just say dot value equals this new property value, because dot value equals whatever. And the way it's set up, you set up this chain, this combined chain, like you combine these three properties, you switch map to the query result, and you observe it. And then you don't need to care about like having to check if the data set underneath changes, because the query results coming from room, for example, they are fully reactive. You don't need to check if the calendar was somehow selected a wrong value. Like if you press the clear button, then I have to reevaluate this. No, you don't. You just change this one value, and everything that depends on it is automatically updated for you. As such, it's much less, it's significantly easier, and you can even manage asynchronicity this way, because it's just one state that this thing is null and now it isn't, instead of having to like manually check, okay, is it still null, or no, you just get the right value right now, you just observe it and you will know exactly what you need. And if you need to know about anything else, you just also add it to the list of combined properties and you get those as well. So that's practically reactive programming in a nutshell. You can define these chains between these observable properties, and you never need to manually say that, okay, this also changed, because you get that done for you by combine, as in like combine latest, the operator.
Yeah, I'm using React. I mean, it's pretty common to use reactive data sources on Android now, right? Because live data was a version of that.
Yes.
More like a lightweight version. Before that, we had RX Java and now Flow, and they all do a bit similar things with some little differences.
Yep.
And yeah, in my little hobby app, it made my life really easy to have this observable data, because everything is synchronized automatically, basically. Because Room also can return Flow and live data and RX observables, I think, right out of the box. So whenever a table changes, you get these updates. And this way, you know, when I show information from a room table somewhere, this is up to date. I don't have to make sure that I fetch this again. It's always the latest data. And this really makes it easy to have different screens that all read from the same data, but you want to make sure that they are actually updated and in sync between each other.